Properties of quadratic relations. Our learning goal today is to graph parabolas and identify their key features and properties. Please ensure you have the lesson printout so you can follow along and fill in with this video. Parabolas are graphs of functions where the highest degree of the variables in any of the term is squared. For example, we have y is equal to x squared, or t is equal to negative 4h squared plus 3h plus 2, or y is equal to 2x squared plus 3x plus 10. In each of these cases, the term with the highest exponents on the variable is just going to be a squared term. Okay, so we see an x squared here, we see an h squared here, and we see an x squared here, and none of the other terms have anything higher than that. And this ensures that we're dealing with what we call a quadratic relation. So it just needs a squared variable in there, and it can't have anything more than a squared, and it can't have anything less than a squared. It must have a squared variable. Okay. Now, let's try graphing the most basic of quadratic relations. It's going to look like this. Y is equal to x squared. And this is what we call the parent function. And it's going to be the function that all other parabolas are going to be based off of. So this is like our most basic version of it. So let's get our y values by plugging it into this equation. So let's write the first calculation here. So if we're going to plug in negative 3 into this equation here, we're going to get y is equal to negative 3 squared. Okay, and then we're just going to do that. So negative 3 squared, so negative 3 times negative 3, that's just going to be positive 9. And we'll do the same thing here. So negative 2 times negative 2, that's going to be positive 4. And we'll just continue that. So negative 1 squared is going to be negative 1 times negative 1, which is going to be 1. 0 times 0, 1 times 1, 2 times 2, and 3 times 3, which is 9. And you can see a repeating pattern. It goes 9, 4, 1, then 0, 1, 4, 9. A mirrored pattern, I should say. So now let's graph these points. So our first value is going to be negative 3, comma 9. So negative 3, so 3 across and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our first point. Our next point is going to be negative 2, comma 4. So we're going to come across 2 and up 4. 1, 2, 3, 4. Then we have negative 1, comma 1. Negative 1, comma 1. Then we have 0, comma 0. Then we'll have 1, comma 1. Then 2, comma 4, then 3, comma 9. And then to finish it off, we're just going to draw a nice line running through all these points here. And this is our graph, and this shape here we call a parabola. I'm sorry, I can see one else. So parabola. So that's what we call this shape here. So now let's discuss some key terminologies about the parabola. So now let's look at some of the key terminologies to describe our parabola. A vertex is the point on the graph with the least or greatest y coordinate. For example, if we had a graph that looks like this, the least y coordinates in our y-axis is going to be the middle point right in the middle here. That'll be our vertex. So whatever coordinate that is, that will be our vertex. And going the opposite way, if it was opening downwards, like this, it'll be the greatest y coordinate. So depending on whether it's opening up or down, it'll be either the least or greatest y coordinate on the graph. Let's take a look at the first example that we did and find the vertex. And so if we look at it here, we can look at the lowest coordinate, the lowest y coordinate, and it's going to be this one right over here. So this is the vertex right here. And we know the value of the vertex, which is 0, 0. The next property that we are going to look at is the direction that a parabola opens. It can easily be seen by looking at the graph. For example, if it opens upward, it means the opening of the parabola is on top. And if it opens downwards, the opening is on the bottom. It can also be found by investigating second differences in a table of values. We know it opens up if the second differences are the same and the values are positive. It opens down if the second differences are the same and the values are negative. We will do an example of this in our next section. The next feature we will be looking at is optimal value. We consider optimal values when we are modeling a situation with a quadratic equation, and it is always associated with the vertex. The optimal value can be a maximum or a minimum, depending on the direction of the opening. Let's do an example. Let's look at this graph here. We'll zoom in. Let's say the x-axis shows your horizontal distance and the y-axis shows the height. And let's say you threw a basketball and it flew in a path that looked like a parabola. The optimal value here will be the vertex, or the highest points. Okay, and in this case, it'll be a maximum. So let's say this point was -2, 5. So a maximum occurs when the quadratic opens down. And this example is the maximum value is +5 when x is equal to -2. Let's try an example of a minimum value. A minimum occurs when the quadratic opens up. For example, let's take a look at our graph here. Imagine this is your horizontal distance and this is your vertical distance. And you are on a ride, and the ride moved in this motion. The lowest point here would be our optimal value. In this case, it would be a minimum. And if we gave it the value of perhaps -3, this is just an example, -6, this could be our minimum value. So it's going to be our y value here. So it's going to be a -6 when x is equal to -3. The next thing we're going to look at are the zeros, also known as the x-intercepts. The zeros are where the graph cuts through the x-axis. Looking at our example here, we can see our zeros would occur here and here. And in the example above, the zeros would occur here and here, where the parabola cuts through the x-axis. These are what we call the zeros.
Sometimes parabolas do not have zeros depending on their position on the graph. Here, we can see that the parabola will not cross the x-axis.
Let's try an example together, looking at the key features that we have just discussed. Let's first begin by filling in our table of values. If we're very careful, we could read the y values off our graph. When x is equal to -4, y will be equal to +6. When x is equal to -3, y will equal 0. When x is equal to -2, y will be equal to -2. When x is equal to -1, y is equal to 0. And when x is equal to 0, y is equal to +6. We will now find our first differences. As you recall from grade 9, first differences is where we take the second y value and subtract the first from it. Let's try it here. Our first difference would be the value when we take y2, which is 0, and we're going to minus the first y from it, which is 6. We're going to get a value of -6. Let's try the next one. -2 minus 0. That's going to be equal to -2. Continuing this pattern, we'll get 0 minus -2, in which we get a value of +2. And finally, we have 6 minus 0, and that's equal to +6. Now, we'll check the second differences. So we do the same pattern again with these numbers here. We have -2 minus -6, which gives us a +4. Then we have 2 minus -2, which is also equal to +4. And finally, we have 6 minus 2, which also gives us +4. What we can see is that they are all the same values. And all the values are positive. This is how we can tell our parabola opens upward. Now, let's look at other properties of this parabola. The vertex, that's going to be the lowest point on our graph, the lowest vertical value. And in this case, we can see the vertex occurs right over here. The coordinates of the vertex will be -2, -2. And so we'll just state that down here on our line, -2, -2. We've already seen from second differences that our table will open upward. Now, let's find the optimal value. Because the graph opens upward, we know that our optimal value will be a minimum. And in this case, it's a minimum of -2 when x is equal to -2. What is our y-intercept? Where does our parabola cross the y-axis? It occurs at one point right over here. And we can state the value for this, which is going to be 0, 6. The next thing we will look for is the axis of symmetry. you know the axis of symmetry goes straight through the vertex. Remember, when stating the axis of symmetry, we always give it an equation. In this case, the axis of symmetry is equal to x is equal to -2. And finally, let's look at our zeros. That is, where does a parabola cross the x-axis? It occurs at 2 points, one right over here and one right over here. We will state both of these as coordinates. So when x is equal to -3, y is equal to 0. And when x is equal to -1, y is equal to 0. For the homework, you will take your time and look at different types of parabolas and find the key features and properties of each. If you have any questions, you could ask me during our Zoom conference time.